some of the most common things that we get asked that come up with regards to mining and cement applications are these. Um, Source capture. In general, the closer to the source of the dust that you can put the pickup of the dust collection, the better it's going to be. If you try to vent a large area, it quickly becomes impractical. The same dust collector that has 1,000 filter bags that can handle your dryer, if you try to vent a single room, can only handle perhaps a room that's 20 by 20 and only pick up light dust. Whereas if it's with hoods and ducting going right to the source, that same dust collector can handle dozens of pickup points throughout your plant. So we almost exclusively need to do dust collection at each source where it's generated. A few things with ductwork design. Ductwork in general is the thing that takes the most amount of engineering and time when we're designing a system. People think it's the baghouse or the dust collector, but often I'd say 80% of our time and efforts go into designing the ductwork. And a lot of the problems that happen in older cement and mining plants are because the ductwork over the years gets changed, modified, neglected. And each time it's changed a little bit or repairs are done in a less than ideal way, it's the death by 1,000 cuts. And that's how you end up with a lot of the problems at these facilities are because the ductwork is not ideal, not so much the baghouse. So designing it correctly in the first place, but also understanding the importance that ductwork is not simply connecting hoses to things. There's a lot of engineering that goes into it. And you may need to review the system you have in its current state in order to see where it's deficient and then make changes. But the basic principle we want to get across is that ductwork changes are something to be done only in consultation with a dust collector or mechanical engineer, dust collector expert or mechanical engineer, because there's a lot going on there. We talked a little bit about filter media selection. In general, we want to make sure we're selecting the best filter media based on the temperature, but then also if there's things like moisture to take into account, other chemicals in the gas, also the particle size and the dust loading that the system sees. All of these play into what kind of media we select. Another thing that comes up often is centralized versus point of source collection. So centralized is where you have a single dust collector that's connected via ductwork to many different dust sources. This is the standard type of system. Point of source collection is where you have the dust collector built into the thing making the dust. Now in older plants, this was done a little bit more often, I would say, than in more modern plants. So you might see older dust collectors built into, say, a really big screw conveyor or on certain belt conveyors. This approach has mostly fallen out of favor because the kinds of collectors that you can make so small and stick on the belts and all that really are not ideal. They don't function well. So a lot of best design practice has kind of abandoned that approach. There are still very few moments where you'd want to do that, but in general, the larger centralized system is going to be the way to go. And that doesn't mean that you have one massive dust collector that collects from all over the plant. It's generally better to have one collector for a certain group of sources. You know, maybe one handle all the conveyors in one part of the plant or one room, for example, or on the dryer, things like that. But those are still centralized systems in that they use the ductwork to pull the dust back to the dust collector. And then another common thing that needs to be looked at is hopper design. Make sure that we have a sufficient design that allow the dust to be removed and not get stuck in there. So that may involve using things like vibrators or aeration devices to keep the material flowing and emptying out of the baghouse. But also, whatever comes under the dust collector, so the rotary airlock, and then whatever's underneath after the discharge, we need to consider that as part of the entire system. Many times people think of those as different things, but a lot of the problems in cement and mining applications with dust collectors can be traced back to the discharge underneath. It goes into a screw that goes over here. That backing up or not being sufficient to remove dust quickly is a cause of a lot of the problems we see. So you have to think of all of it together. The ductwork, the hoods, the ductwork, dust collector, the discharge underneath where it goes, as well as the system fan, obviously, all of that together as one dust collection system. And by doing that, you can avoid some of those problems. And then finally, one last thing that we often see when we do inspections is the cleaning system set up. Most, if not all, modern dust collectors in these applications are going to be pulse jet style, where they pulse the filters with compressed air. Many, many times we find plants where they have it set on cleaning just on timer mode. So just clean the filters every 30, 60 seconds, all day, every day. And this results in a lot of over cleaning, wasted compressed air. The over cleaning wears out the filters much faster than they otherwise would. It's a huge waste of resources of compressed air. Um, Plants sometimes get nervous thinking that if they do something else, it won't be sufficient and the system will back up. A much better option is to have it be a clean on demand system where the system automatically cleans when the differential pressure is high and then shuts off when it's not. Because they're often neglected or not set correctly, plants think that those systems are unreliable. So they prefer to just keep it on the timer setting. But they're really doing themselves a massive disservice by doing that. Better to fix the problems of neglecting them as opposed to just ignoring those kinds of systems. Um, we find in many cases where plants are wasting tens of thousands of dollars in compressed air, as well as dramatically shortening the life of their filters because they just have it on a timer setting. So it certainly is worth the effort to put the clean on demand there and then to maintain it well so that you can see the benefits.